about the Minnesota Rivers and Streams Probabilistic Surveys, or the EMAP studies. Been looking forward to hearing from Nathan for a while. I give a call out every chance I get. I was telling Nathan a little earlier to the extraordinary work that these guys do in these studies. It is a ton of work to do these studies and get these samples. And Nathan is going to tell us a little bit about the biological monitoring program and how they implement a comprehensive monitoring approach on rivers and streams that includes, among other things, measures of fish and aquatic macroinvertebrate communities, water chemistry, and in-stream habitat. The MPCA has employed these measures in probabilistic surveys that enable us to monitor what amounts to a relatively few number of sites to characterize the condition of rivers and streams throughout Minnesota. Nathan is an environmental specialist 3 with the MPCA and has been a member of the North Biological Monitoring Unit since 2010. His work is primarily focused on stream fish communities within the northern half of Minnesota. Nathan, hey, it is great to have you with us. Why don't you take it away and run with it?
All right, thanks for the introduction, Mark. So as mentioned, I'm here to talk about the Minnesota Rivers and Streams Probabilistic Survey, which aims to characterize the current condition and to develop a long-term trend for the state's waters. So probabilistic surveys are used to extrapolate, the condition of an area out to the broader geographical areas. So it's quite tough to sample every lake, stream, or wetland, and because it requires an immense amount of time and money. So with this survey, we were able to say what the condition is for the entire state or ecoregion and kind of track that trends throughout time. So the state of Minnesota has been performing biological monitoring, including the collection of fish, aquatic macroinvertebrates, water chemistry, and habitat for the assessment of water quality for over 30 years. So the MPCA has collected stream data since 1996 using a probabilistic survey called the Environmental Monitoring and Assessment Program, or EMAP, which was originally designed by the US EPA for the purpose of conducting national surveys. The MPCA also developed its own sampling protocols and to address the unique habitats and stream conditions found in Minnesota. The initial monitoring framework called for the assessment of Minnesota's 10 major basins to be sampled and assessed one at a time. And we complemented that with targeted poor and good sites to help develop a statewide IBI, or Index of Biological Integrity. Monitoring started by sampling approximately 50 EMAP sites in the St. Croix River Basin in 1996 and continued for until 2005 when we completed all 10 basins. A total of 435 sites were sampled across the state using this basin by basin approach. So EMAP collected data throughout the nation from 1990 to about 2006. EMAP's goal was to develop a scientific understanding for translating environmental monitoring data from multiple spatial scales and temporal scales into the assessment of current ecological condition and to forecast future risks to our natural resources. Monitoring of the nation's aquatic resources is now being routinely conducted by the National Aquatic Resource Surveys, or NARS, which is run by the EPA's Office of Water. Portion of that survey is the National Rivers and Stream Assessment, or NRSA, which is the primary tool used to assess the nation's rivers and streams. EMAP kind of continues to this day in conjunction with EPA's NRSA program, which enables the MPCA to conduct the statewide survey as an enhancement of the national survey. And we do this once every 5 years. So as I kind of previously mentioned, the original framework for these surveys were major river basins. But beginning in 2010, the MPCA changed the survey to a statewide design using level 2 ecoregions and stream orders. Locations are randomly selected to ensure that derived estimates are unbiased. In addition, unequal probability weighting was used for the random site selection process to increase the likelihood of obtaining equal number of sites in each ecoregion. And for the 4 stream orders, the 4 stream order categories that we utilize are first, second, third, and anything larger than fourth is combined together. Potential site locations are selected using the NHD plus line work. All line work is assigned a code that indicates the channel type, and with only pipelines and coastlines excluded from the survey, all other channel types were included in the survey design. With this design, the survey provides a statistically based estimate of rivers and stream conditions statewide, as well by ecoregions. So river and stream conditions were analyzed using biological, physical, and chemical attributes for roughly 150 sampleable sites for each survey period. Overdraw sites are provided in anticipation that not all sites will be proved to be sampleable. We go down the list until we reach that desired number of 150 sites. For a site to be considered sampleable, we have to first deem it as what we call targeted, meaning it must have a definable stream channel and sufficient water. And sufficient water is at least 50% of the reach that we're sampling needs to have water present. The same survey design was utilized again in 2015 and 2020 and will be utilized again in 2025 as well. But we added a feature of 50% revisit rate for sample sites from the previous survey, and that was utilized in 2015 and to the present day now. These revisit sites are added to increase the ability to detect temporal trends in future surveys. Though the design of the survey was developed by the EPA, the sampling protocols and the indicators that are used in the survey were developed by the MPCA to address the unique habitat that we have here in the state. So I kind of mentioned what a target site is. So we either deem sites non-target or targeted. Sites that are non-targeted are due to discrepancies between the line work and on the ground location or condition. Examples of this would be line work within a wetland, a lake, an impoundment, where no stream channel or water body exists, or if the water is insufficient. And in addition, not all targeted sites are sampleable. Common reasons why targeted sites are not sampleable is landowner permission denied. The site is inaccessible with the gear type that we need to get a sample, or it's just unsafe due to some geological features such as a waterfall or a rapid. So those non-targeted sites and non-sampleable sites are replaced with overdraw sites in order until we reach the designated number of targeted sampleable sites that needs to be reached. I kind of covered targeted sites, but again, it's a definable stream channel and it must have sufficient water. And then we have a third category of targeted sites. These sites were deemed sampleable because they had that definable channel and they had water present. But after sampling it, the tool was really inappropriate at assessing the condition. Kind of example of this is the stream acts more as a wetland than an actual functioning stream. So as I kind of previously mentioned, we utilize both biology, physical, and chemical attributes. Our main biological attributes that we use for assessment of water quality are fish and macroinvertebrate communities. That's the tool that we utilize is the Index of Biological Integrity. And with this, we do some field sampling, ID the species down, and that provides us with our raw biological data. Those individual species have different tolerance to pollutants, life history aspects, reproductive strategies. Their presence or absence and their abundance are driven both by biotic and abiotic factors. So within the IBI itself, there are community metrics that are based on species attributes that show a response to a disturbance gradient. Metrics that are most responsive to that disturbance gradient are selected to be within each individual IBI class. Metrics that are combined to produce an IBI score of 0 to 100. And then the IBI is held to a specific impairment threshold. Anything below that threshold is considered impaired. Anything above it is considered supporting aquatic life use standards. So currently, Minnesota has 9 fish classes and 9 macroinvertebrate IBI classes that are held specific thresholds. Those classes are broken down to drainage size, stream temperature, also stream gradient. So it really reflects the different kind of habitats that we have in Minnesota. With this project, we collect multiple chemical parameters, but we mostly report out on total suspended solids and total phosphorus. And we held those parameters to the regional standards. And then we also collect physical habitat attributes. Mostly we use the MPCA stream habitat assessment. It's a qualitative measurement that looks at in-stream habitat and riparian use. And then we break those down into key categories of good habitat, fair, or poor habitat. And then at times we do get requests to collect additional information. As some subset of sites, we typically collect contaminants of emerging concern. Although we don't really report out on this, it's additional information that we gather for the agency. So with this information, kind of like I previously mentioned, we can get derived estimates for statewide numbers as well as the ecoregions. Some of the estimates that we produce are the percentage of stream miles, stream orders, if the stream is natural or ditched. But a lot of these numbers are pretty consistent throughout the surveys. And this is due to us using unequal probability weighting, and that kind of gives us that even distribution across the surveys. So we also estimated the percent of stream miles meeting standards. So I'm going to kind of provide an example here, just so we have some kind of, and then I'm going to put some context behind it as well. So this example is looking at the fish IBI work, where we are looking at the percentage of streams meeting or not meeting standards. We also throw in there the percentage of streams not sampled or not assessed. Quickly, I'll go over this figure to kind of give you an understanding how it's laid out. Top row are the statewide estimates. And then the bottom rows are broken out to the ecoregions and for key categories such as meeting IBI, not meeting IBI standards. So the first graph on the left is the estimated percentage of miles for the 2020 survey that are meeting or not meeting IBI standards. While the middle figure is kind of the same numbers, but for 2010, 2015, and 2020. So you kind of can get a general idea of the trends across time. And then the last graph is the estimated percentage of change between the 2015 and 2020 survey. We also calculate this for change for 2010 to 2015 and then 2010 to 2020 as well. And anything with a solid dot is statistically significant. I'll give you some context on some of these numbers. So statewide, fish communities are meeting aquatic life use expectations for about 38 to 45% of the time, and they fail meeting expectations about 15 to 23% of the time. So the mixedwood shield has the highest estimated miles meeting expectations, followed by mixedwood plains and the temperate prairies. This tracks pretty well with the land use and the watershed disturbance that you see across the state. You also see that temperate prairies are statistically significantly declined in IBI scores that are meeting standards. You also see this for the mixedwood plains, where the amount of streams not meeting the standard has decreased. These results appear to be driven predominantly by the parallel significant increase in the percentage of stream miles not sampled, rather than any real meaningful decline in biological condition or improvement. So when evaluating change statewide, the only significant change that we saw was between the 2010 and the 2020 survey on the number of streams not sampled. This result is particularly driven by the increased rate of landowner denial in 2020 survey due to the pandemic precluding in-person visits to gain access to sites. But however, we don't really see the same pattern in the IBI score data. So it can be also partly attributed to the drought conditions experienced in 2021. Some sites that were sampleable for inverts during the relatively normal water year of 2020 were not sampleable for fish during the drought year of 2021. So with that, we also calculate the mean IBI scores or mean habitat scores, and we can see those trends across time as well. So right here is an example of both mean fish IBI scores and macroinvertebrate IBI scores. Little fun fact that they seem to be, there's a significant increase in the mean IBI scores across both parameters that exhibited statewide between 2010 and 2020. But it didn't really translate into more streams meeting expectations either. So this information was historically published in fairly large PDF reports and were posted on the agency's webpage. If you have a phone available, I can also pop this into the chat, but if you scan that QR code on the right, you'll be brought to the webpage where these reports are housed. You'll also see our dashboard there, which I'll kind of go over quick here, but let's see if I can pop this in quick. So there's the link to the webpage. So these reports or reports of this size and structure seem to be less utilized, at least by the general public. And to be really effective at our job, we need to communicate the science to the people and deliver it to their interest level. In addition, we were looking for a different way to report this information that was more streamlined. So during the 2020 reporting cycle, we attempted to create a more user-friendly dashboard to report out our findings. So we knew of the National Rivers and Streams Assessment dashboard, which was actually a pretty nice layout on how they display their information and produce that and give it out to the general public. So we kind of wanted to design it after that because our statistics are pretty similar as well. I can kind of show you that dashboard as well. So there's a lot of functionality within the EPA's dashboard. You can move between good, fair, and poor, and it'll give you the statistics for it. You can click on it, or you can hover over it. It gives you the confidence interval, the statistics with it. And then you can filter by different change between years and survey years if you want. You can also get down to stream size if you want. It's a larger survey, so they have a little bit more functionality than we ended up on. But you can go through it, change it, manipulate the data so you can get kind of what you're looking for. So what we came up with was a similar format as the NRSA's dashboard that displayed this key information. That QR code on the left, it will bring you directly to the dashboard itself. I'll run through a kind of example of the information you can get there as well. But and then also the one on the right, if you went to that one, you still can get to the dashboard from our agency webpage. So when you come to the dashboard, you'll come to the main page, which includes the map. There's a narrative at the top that kind of tells you about what the survey is about. And then there's a link back to the agency's webpage as well. If you scroll down, see the map. You'll see all the survey points we collected over the past 3 surveys. You can filter by specific year if you want. So let's look at 2020. And then you'll see 2 different colored dots here. You can see that we have the 2015 sites that we revisited, and then the new 2020 sites there. So an example of one is the watershed that I live in is the Pine River. You can see the stream name, obviously the Pine River, the basin it's in, stream habitat rating, just some general field numbers, when it was surveyed, and then stream order. And if you want more information, you can also click on it and it'll bring you to the surface water monitoring page, which will give you the lat long for the specific site. It'll give you more information about what Huck 8 it's in, drainage area, land use. You can also scroll down, look at specific information, such as the IBI scores, different chemical parameters that we've sampled there, what project it was for EMAP. And then you can look at the biology if you want. You can look at what the fish community looked like, what the invertebrate community looked like. And then you can look at those specific species attributes as well. Example like here is there are 2 darter species captured, 6 game fish species captured. And you can look for the similar information for the macroinvertebrate data as well. So jumping back to the workbook. So from the main page, we have these 6 main tabs on the side. The map is obviously this page, but then you get into the chemical parameters, the top, these 2 here, the biological parameters, these 2 here, and then the physical parameters. So if you click on one, we'll bring you to that specific parameter. Gives you a little narrative on top of what we're sampling here. But the first graph you'll come to, and these are real similar to the stuff I was showing in the slide. It will give you the statewide category ranks. So what's the percentage of streams in Minnesota meeting standards or not meeting standards, or we didn't sample or not assessed? And you can filter this for specific years if you please, or you can go to specific ecoregions as well. And you can see the percentages for the mixed-wood shield. About 44 to 62% are meeting standards, with a relatively low number not meeting standards. And the next graph down, it kind of shows you the mean IBI scores across time. So as I showed that it has been increasing since 2010, you kind of can see the same trend here. And then this last one kind of shows you the differences between the surveys. So it's looking at the first graph here, 2010 to 2015 survey, and then 2015 to 2020. And then you can see statistically significant starred. Then here's a statewide, and then the broken out to the individual ecoregions. Just jump to stream habitat quick because it's a little different, but so we have it broken down to good, fair, poor habitat. You'll see that there's not assessed here because those were included in the habitat ranking. So those got a good, fair, or poor. And then you can see the same statistics kind of displayed here as well throughout the dashboard. So what's up next? We have our 2025 EMAP monitoring coming up. We started some recon last fall already. We'll continue that into the spring. And then we'll do some field sampling starting this year in June, starting for fish, and then macroinvertebrates in August. We collect our chemical parameters at the same time as fish, same with our habitat parameters. And then we'll do any follow-up monitoring that we need in 2026. I also wanted to provide some examples of the 2025 draw. So here is a tributary to the Valley River. Pretty remote, far back there. We actually flew the drone on this one to look at stream channel, severely impounded. You can see it pointed out there. So this is would be considered a non-targeted site. So this would be a redraw. Here's an unnamed creek in northwest Minnesota. Obviously, there's a channel there, but there's no water body present. It's a farm through channel, extreme headwaters of a unnamed creek. So this is another non-targeted site. And then we have, some of the more logistical, challenging sites. Like this one is a trip to Namakan Lake. It's a 6-mile boat ride in, a half a mile portage, and then a 1.5 mile paddle to the actual site. It looks fairly sampleable from the aerial photo, but we'll have to get on the ground to see if we can weight it. If we can't weight it, we can't get the gear type back there. It would be considered a target, not sampled site, so that would go to another redraw. Here's an example of one that we checked out. It's a trip to East Bearskin Lake. It's a 14-mile round trip paddle into the boundary waters. When we got back there, there was no channel present, no water body present, so this would go to a redraw as well. But then we have some pretty clear-cut sites. This is a tributary to the Rainy River. It has a stream channel, it has water present, and this is one of the sites we'll be visiting in 2025. So following all this monitoring, we'll get back into the reporting cycle in the winter of 2026, which will include updates to the workbook. There are some changes that we've identified that we would like to put to that already. There's also additional parameters we could consider. One of those that come to top of mind is tolerance index values for biology. We could add that information in there so we can report out additional parameters, so there's more out there. So projects like this are very unattainable without the human dimension of the work. Numerous staff have worked on this project over the years, so I would like to thank them, including the biologists, temporary staff, student workers. Kind of with those examples I showed, there are sites out there that are logistically challenging, physically challenging to get to, and it takes a significant amount of work to get there. So this is kind of a small fraction of the faces of the people who worked on the project over the years. And those are the QR codes if you want to jump to those at all still. And I can take any questions or comments at this time.
Thanks, Nathan. Doesn't look like we have any questions right now. So if anybody has questions and you want to throw them in the chat, you can go ahead and do that. Or if you want to unmute and just ask, you can do that as well.
Nathan, I have one to get us going before people put things into the chat. When you were talking about the sites that you go to and when you decide whether they're sampleable or unsampleable, one of the questions I have is if a site comes up that you're scheduled to go to, and it has obviously been impacted recently by some huge event, right? I'm thinking of the Rapidan Dam, or I'm thinking about the Cohasset spill recently. Does that factor into your screening them out, or do you just include those because it's in the pool?
Those sites would be included because it's within the pool. So yeah, it's a a step to keep it statistically valid and unbiased. So.
All right, we do have a question in the chat. Is there any federal funding for this that we should be worried about?
So my management probably would know more about it. Of what I've been told, that this has been allocated to a point, but it's a pool of money that we draw from when the work is completed. So there is some questions behind if that money's still there. If any management or supervisors are on the call, if they want to add to that comment, by me.
You're phoning a friend? Is that it, Nate?
Yes.
Yeah, at this time, I don't, hopefully that will not be a concern, and we'll just keep our eyes open. But as we are moving forward with, we're understanding that the money is there and that we can access it. So, yeah.
Awesome. Thank you. And then a comment from April that says, thanks, Nate. The dashboard's a great idea. Definitely. Any other questions?
Well, okay,
or
if nobody else has
comments?
questions, I sure do. It's Mark again. So how long does it take you once you get back to one of these sites, and sometimes it can take hours and hours and hours to get back there? How long does it take you guys to actually do the work at the site, take the samples, do the assessments, before you get to spend another few hours packing everything out? What kind of time commitment do you find at each one of these locations to do the work?
Typically, these take a lot longer than our watershed work. We do get lucky sometimes, and the site's right next to the road, easy access. And particularly for the 2025 draw, it seems like it's an easier draw than 2020 was. We had some really challenging sites, and some of those sites, well, all of those sites we have to go back to this 2025. I can think of a site specifically that was on the Wild Rice River in northwest Minnesota that it was a day trip for us. But by the time we got done and back to the office, it was about 10 o'clock at night, because we had to haul up the UTV, go through this private property to get back there a few miles, haul the gear back there. And then on top of that, we got like 7,000 or 8,000 fish. So it took a long time to work up all the fish. And it was a very diverse community as well. So some of these sites can be very logistically challenging, and then other ones we can be lucky and it can be straightforward, simple. So, but overall, like compared to our normal watershed work, it takes a lot more time. It's typically, I'd say, maybe average. If an average site for our IWM work or Cycle 2 work takes about 4 hours, I'd say an EMAP is probably more likely to be like 6.
All right. We had another question from Amy. Are there any goals of breaking down the dashboard into a smaller watershed scale?
I would think we would need more sites to make it more statistically valid at a smaller scale. So that would have to be like a change in the process of itself. And what we really hope with this data is to get long-term trends for the state. You know, 3 sample points are great, but the more we do the survey and continue it, more the trends will kind of play out and give us more information for statewide and ecoregions, those larger scales.
All right. Any other questions? Mark, did you have another one? Or anyone else?
No, one of the things that like I said, in my introduction, I think is trying to make people aware of, the really enormous amount of work it is to get these samples and to work up the data and to do the reporting that you guys do so admirably well. And I'm kind of wondering, if you were to tell people, in terms of storytelling, what kind of war story would you tell in terms of, wow, here was a site that was absolutely amazing because I think a lot of people don't see the work and the trouble it takes to get these samples and what you guys go through. You did tell us a little bit about the Wild Rice River trip, but I'm kind of wondering, you must have more stories than that.
The nice thing about this project is you get to see a lot of water bodies that nobody else gets to see. And there are some streams that are just logistically challenging, and they make great memories, honestly, because the amount of work to just get back there. But then you get these, like, to see, it was, I think it was Cross River. There was an EMAP site on it. It was a short paddle to get in across this wide pond area of the stream itself. But you get back there and there's like this 8-foot tall waterfall that I'm sure that hardly anybody has ever seen. So that part of the work is real enjoyable, really. I mean, at the time, it can be some pain and suffering to get back there. But overall, I mean, it's just cool to see these different water bodies that nobody else gets to see, and collect the biology there. Some of it, areas of the state that really haven't been sampled, and report out on it.
This is Scott. I'll add to that. This is Scott Niemela. So as Nate said, we've been doing this for, about 30 years now. And, when I was out in the field a lot, I mean, I still remember EMAP sites that I did close to 30 years ago. That's how impressionable some of these sites are. They are places where you're probably collecting data like this for the first time, most likely the first time that this data has ever been collected in some of these rivers and streams. So there's a real sense of accomplishment when you are able to get into some of these sites and actually collect this valuable data from them. And we've learned an awful lot about Minnesota's streams from this sort of project. The real value here is that, you think about it, we can characterize the state's resources with 150 sites. Because we have this statistically valid approach, there's a lot of economy in that sort of analysis. We don't have to go out to every single stream site across the state. Our watershed approach is great, but you think about that, we're looking at thousands of sites. And we could roll that up into a statewide assessment as well, but that's thousands and thousands of sites that we've sampled. We can do this with 150 sites. We can get a pretty darn good estimate of condition. There's a lot of power in that. And I think the real value is in changes over time. So, 10, 20, 30 years from now. Right now we have, as Nate said, about 3 data points. But when you start looking at this data long term and you see the trends that are occurring, if any, that's what's going to be really important. So some of the statistics get a little bit dry, percentage of stream miles meeting standards and whatnot. They don't come out as being like, oh man, this is really interesting stuff. But when you think about this in the long term, it's incredibly valuable information.
Awesome. Thank you so much for that perspective. Any other questions or?
This is Fox. Can I throw out a
Yeah,
question that's
Fox.
like a little related to Mark's question? I'm curious if you could tell this group about the seasonal staffing efforts, and do you ever follow cohorts of these young people as they move through their careers, or I don't know what my specific question is. I'm just curious because a lot of these folks are and sometimes still students, right? Or maybe just graduated and they're learning about and being enthusiastic about environmental careers. I'm just curious what that looks like, because we don't see that in most of the rest of the agency in quite the same way that you all do.
So, being out in the field with temporary staff, student workers, over the years, you're really with them all day long, because we try to utilize the daylight that we have. You also go out to eat with them every night because you're on the road, so you really get to know these student workers, temporary staff really well. Some of them stay with the agency, some of them get full-time jobs with the agency, some move on to other positions, some from other states. But being able to stay connected with these students and temporary staff occurs a lot in our field for the fact that we work so closely together. We work as a team, a unit all the time. So outcomes from it, there's definitely like student workers that end up with the agency. If it's not directly with our unit, it's other positions with the agency. But I've also know of and seen other students move on to pursue PhDs or masters, and then they end up getting a full-time job, some with the federal government, some with other state agencies, and then some don't even pursue the field after the fact. But the nice thing about our position here and also this work, I mean, you're really in the trenches with them day in and day out, especially some of these tough sites. So you get to know each other well. We get to, and a lot of us keep in touch, even from a full-time staff to the students. I still keep in touch with plenty of the past people who are employed with us. And yeah, there's definitely some there's good outcomes from what we teach them. And even if it's not directly applicable to the career that they end up going to, I think the whole working with us, the team aspect, all that. So yeah, I don't know if that would answer your question, but it's.
Yeah, that's great. Thank you.
We had another one in the chat. This is really amazing work. I assume it is supported by clean water funds. If so, how much?
This is a federally funded project. I mean, I'd leave it to the management. I know I'd assume there's some clean water fund that support staff here, but.
Nate, can I help you out on that one?
Sure.
Sure. So there are some aspects of clean water funds, but it is very little in comparison to the federal funds. There's aspects that Mark could talk a lot more about the CEC work that tags on to this work. And that is clean water funded. And certainly our equipment is mostly clean water funded. And there is aspects, but really to be able to do this work is federally funded.
Yeah, I can chime in a little bit to that. So this is Mark. I've been studying contaminants of emerging concern in surface water around the state for about 15 years. And have come to really appreciate the work that these guys have done and the National Lake Assessment studies to run out there and get samples so that we can monitor what kind of emerging contaminants are in these waters, in addition to the monitoring work that you just heard Nathan talking about as part of these assessments. That work and that sampling is covered by Clean Water Action. Clean Water Funds. And that is not federally funded, but that is work that the state of Minnesota and the legislature has decided is important enough to fund. And so we're able to kind of piggyback onto the good work that you're seeing here to get those samples for those kind of analyses.
All right, thank you for the double assist there with that one. All right. Have there been any instances where samples were contaminated or compromised? And if so, would the team go back out to the site for recollection or just throw the sample out?
I can't think of any specific instances, especially when we're pertaining to water chemistry. I'm sure there are some where there has been. I mean, that happens within any kind of field work. We do follow-up monitoring if we deem necessary, but for the most part, and especially when it comes to the chemical parameters, that would be so rare. Yeah.
I would say though, for the biology, there are a lot of things that can kind of go wrong in a sampling event that that would warrant us kind of looking at that data and then going back to the sample or going back to that site and resampling it. So, I mean, that doesn't happen all the time, but I'm sure there's been EMAP sites where we've had to go back and get another sample because something kind of went haywire during the biological survey. So more than just even the chemistry, the biology sometimes can be challenging to collect, and there can be issues that go wrong when we're out there doing the sampling that warrant us going back out and getting another sample.
All right. Any other questions out there? Otherwise, we can wrap things up early this morning. Usually once I start to close things out, then somebody has a question. So I do drag it out a little bit. Okay. No takers. Nathan, thank you so much for your time this morning. This was an incredibly interesting talk.
Yeah, thank you for having me.
Everybody have a great rest of your Thursday.
Thank you.
Thank you.